Hello, my viewers and students. You're welcome to another lesson on the group 16 elements, popularly called the Chalcogens or the oxygen family. Don't forget to like, share, subscribe, and comment on these lectures. In our previous lesson, we were talking about the group 15 elements, and today we will study group 16 elements containing oxygen, sulfur, selenium, tellurium, and polonium. And their name was derived from the Greek name for copper, since most of the copper ores contain members of this group. Compared to group 14 and 15 elements, these groups are more non-metallic in their behavior. So by the end of this lesson, I expect that you should be able to identify the group 16 elements of this periodic table, write their electronic configuration, describe their periodic trend, and identify the oxidation states of some compounds of the group 16 elements. The Chalcogens, they are oxygen with a symbol O, atomic number 8, and it's a non-metal with electronic configuration He 2s2 2p4. Then we'll have sulfur, symbol S, atomic number 16, a non-metal also, with electronic configuration Ne 3s2 3p4. Then we'll have selenium, symbol Se, atomic number 34. Selenium is a metalloid with electronic configuration Ar, that is argon 3d10 4s2 4p4. And then we'll have tellurium, symbol Ta, atomic number 52. It's also a metalloid with krypton electronic configuration 4d10 5s2 5p4. And then polonium, symbol Po, atomic number 84. It's a metal with electronic configuration of xenium 4f14 5d10 6s2 6p4. And polonium is also a radioactive element. And then with a predicted element called livermorium, atomic number 116, electronic configuration of radium 5f14 6d10 7s2 7p4. One thing you observe in this group is that they have the general formula NS2 2p4. How are they isolated, the members of this group? Oxygen and sulfur. Apart from oxygen and sulfur, other elements of this group are relatively scarce. Oxygen can be isolated via the separation of air into oxygen and nitrogen. And then sulfur can be extracted from natural gas and oil. Sulfur is found in volcanic regions of the earth in free state, Japan and Sicily. In combined state, it can be found as sulfates and sulfides, such as gypsum, barite, and Epsom salt. The sulfides are galena, PBS, zinc blende, ZNS, and chalcopyrites, CuFeS, and as iron pyrites, FeS, and as cinnabar, HgS. Sulfur is also present in mineral spring as H2S, hydrogen sulfide. Sulfur is one of the 23 elements essentials for life, along with carbon, nitrogen, oxygen, hydrogen, and phosphorus. Sulfur is present in eggs, wool, garlic, and garbage. The refining of copper is known to yield tellurium and selenium as products. Selenium and tellurium also occur as sulfide ores. Polonium occur as a decay product in thorium and uranium minerals. Livermorone and polonium can be created with the help of particle accelerators. Polonium was named after the home country of the great chemist Maria Curie, as she discovered this element. There are periodic trends. We will be considering the melting point, the boiling point, density, ionic radius, ionization energy. Due to the increase in atomic sizes and atomic masses down the group, the melting and boiling points of the element also increases while progressing down the group. As a result of increased intermolecular forces of attraction. Among the chalcogens, oxygen is known to have the lowest melting and boiling point. It also has the lowest density. Density increases down the group. Ionic radius increases down the group. And ionization energy decreases down the group. Electronegativity decreases down the group, with oxygen being the most electronegative of this group. The reaction with hydrogen, halogens, and formation of oxides, we found out that oxygen will form water, which is a liquid, and hydrogen peroxide, whereas hydrides of the other elements of this group are gases. They form several reactions with halogens. Oxygen can react with fluorine, can react with chlorine, bromine, and iodine. Sulfur can react with fluorine, can react with chlorine, can react with bromine, but does not form compounds with iodine. Selenium forms compounds with fluorine, chlorine, bromine. Tellurium forms compounds with fluorine, chlorine, bromine. And polonium forms compounds with chlorine, bromine, and iodine. We find out that sulfur, selenium, tellurium, and polonium compounds with all halogens are known except iodides of sulfur, selenium, and fluorides of polonium. They can also form oxides. Some of them form monooxide, they can form dioxide, they can form trioxide, and they can form other oxides, tetraoxides, just as we are seeing on the board here in this diagram. We can see the table. We are seeing sulfur oxide, sulfur dioxide, sulfur trioxide, sulfur tetraoxide. So these dioxide are generally obtained by heating the element in air. The dioxide of selenium and tellurium can also be prepared by treating the element with concentrated nitric acid, followed by heating the oxo acid. The equation are shown in the equation. We can see selenium reacting with nitric acid, and we have formed the compound H2SeO3. To further react it, or it will now decompose to form the oxide of selenium plus water. The chalcogens have the general formula NS2MP4, and they can obtain a stable electronic configuration by gaining 2 electrons or participating in covalent bonding. When they gain 2 electrons, the general formula of the ion formed is M2 negative. M donates the chalcogen. The regular oxidation state shown by the chalcogens include -2, -1, +2, +4, and +6. And most of them exhibit all these oxidation states like sulfur. Sulfur can exhibit all these oxidation states. Oxygen exhibits in -2, -1, +2. Selenium -2, -1, +4, +6. And tellurium -2, -1, +4, +6. Some allotropes of group 16 elements. Almost all chalcogens have more than one allotrope. The most common allotropes of oxygen are dioxygen and ozone. In fact, oxygen has 9 known allotropes. Furthermore, sulfur is known to have over 20 known allotropes. Selenium is known to have at least 5 different allotropes, and polonium is known to have 2 allotropes. The most stable allotropic form of sulfur are monoclinic sulfur and rhombic sulfur. It can be noted that selenium and tellurium can exist in both crystalline and amorphous forms. So looking at the board, you are seeing here on this table, oxygen, the most common is O2. It can also exist as O3, tetraoxygen, and octaoxygen. Sulfur will have the crystalline form and the amorphous form. The crystalline form form the rhombic, most stable form, and then we have the monoclinic sulfur. While in the amorphous, we can form plastic sulfur, colloidal sulfur, and milk of sulfur. For selenium, 2 amorphous, red and black. For selenium also has 3 crystalline form: deep red, crystalline, trigonal, and selenium gray. And then it has 3 allotropes of the crystalline cubic. And then tellurium has the crystalline and the amorphous, and polonium has the alpha and beta polonium. Anomalous behavior of oxygen. Oxygen differs considerably from the rest of the family members. It has small size, very high electronegativity, and does not have d orbitals in the valence shell. Oxygen is a gas, while other members are solids. Oxygen is diatomic, other members are polyatomic, like sulfur and selenium. Though selenium compounds that are polyatomic are very complex. A polyatomic element is a chemical element that naturally exists as a compound molecule containing more than 3 atoms of the same element. Oxygen, being highly electronegative, shows only negative oxidation state of -2 and -1, except in OF2, oxygen difluoride, where it is +2, because fluorine is more electronegative than it. Oxygen shows paramagnetic properties while gaseous, liquid, and in solid states. Aurora borealis. An aurora, commonly known as the northern light or southern light, is a natural light display in the earth sky, predominantly seen in high latitude regions. Auroras display dynamic patterns of brilliant lights that appear as curtains, rays, spirals, or dynamic flickers covering the entire sky. The aurora borealis is visible from areas around the Arctic, such as Alaska, the Canadian territories, Iceland, Greenland, Norway, Sweden, Finland, Scotland, and Siberia. On rare occasions, the aurora borealis can be seen as far south as the Mediterranean and the southern states of the US. How is this aurora formed? In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from the Earth's atmosphere. The energy released during this collision causes a colorful glowing halo around the poles and aurora. Most auroras happen about 97 to 1,000 kilometers above Earth's surface. It is always said that it is a beautiful atmosphere to behold, and is common in Norway, where they celebrate it during the spring. Uses of the chalcogen. Oxygen gas is used in the manufacture of iron, steel, and other chemicals. It is also used in water treatment as an oxidizer in rocket fuel for medicinal purposes and in petroleum refining. Oxygen is essential for life, for respiration and combustion. Sulfur is used in the production of fertilizers and dyes. Selenium is employed in the manufacture of solar cells and electronic devices. And polonium has scientific application for alpha radiations. The uniqueness of oxygen. Oxygen is very unique. It's a unique member of this group. It is the most abundant element in the human body, 65% by mass. It makes up around 50% of the earth crust, water, and atmosphere. And oxygen is the most abundant element on earth. It has three isotopes, the O16, O17, and O18, while the most abundant is the O16. Is key component of other biological compounds, such as our DNA and amino acids. The DNA and amino acid contain oxygen compounds. It's said that a typical 70-kilogram human contains 43 kilograms of oxygen, mostly in the form of water. That is why our body needs water. Oxygen is not flammable, but is what we call an oxidizer because it helps others to burn. Animals take it and convert it to carbon dioxide. Plants utilize the carbon dioxide as a source of carbon and returns it to oxygen to the atmosphere. Oxygen can be toxic when taken in excess. Study questions. Find out the oxidation states of sulfur in the following compound: S2O, S2O3, SO2, and SO3. Explain the anomalous behavior of oxygen from other members of this group. Find the products of the following reactions and indicate the oxidation states of oxygen, selenium, and sulfur in the reactants and the products. Cl2O plus H2O, find the product. 2Se2 Cl2 plus H2O, find the product. 2SO2 plus H2S, find the products. And also remember to find the oxidation states of oxygen, selenium, and sulfur. Thank you, as we have come to the end of this lesson on the chalcogens, the group 16 elements of the periodic table. Don't fail to subscribe, like, comment, and share this video. See you in the next class.